Hello viewers, once again welcome to my channel Mugambi Brian 256. So we are going to continue with our discussion, and today what you're going to look at in our topic of heat, we're going to look at the latent heat. Basically, when we look at the latent heat, we are looking at the amount of energy that we need in order to change the state of a substance from one state to another. A case in point, for example, from solid to liquid, and then from liquid to gases. So we are going to be looking at that amount of energy that is needed. However, it should come to our knowledge that as we are having a change of state, it does occur at a constant temperature. So we need to have that at the back of our mind. To start with is the definition of the latent heat. So I say this is the amount of energy that is absorbed or that is lost when a substance is changing from one state to another at a constant temperature. Just as I told you, the latent heat is basically an imaginary heat. However, it occurs at a constant temperature, and that is the amount of heat energy that you need in order to change the state of a substance. So we shall go to the specific latent heat. So when we talk about the specific latent heat, we are basically looking at the amount of heat energy that we need in order to change the state of a substance of 1 kilogram mass of a substance at constant temperature. Now, one thing to emphasize here when we talk about the specific latent heat is basically the 1 kilogram mass of a substance. We are specific, it is 1 kilogram. So that is the amount of heat energy that we need in order to change the state of 1 kilogram mass of a substance at constant temperature. So we have two types of the specific latent heat, and that is the latent heat of fusion and then the latent heat of vaporization. So to start with is the latent heat of fusion, and we are going to be denoting it with L subscript F. Well, now the latent heat of fusion is basically the amount of heat required in order to change 1 kilogram mass of a substance from solid to liquid at a constant temperature. Now, for the latent heat of fusion, it can apply to a substance. For example, if we have ice cubes, yes, they are in a solid state, but if we need the amount of energy that we shall need in order for us to change this ice to liquid is what we call basically ice of 1 kilogram mass. This element of 1 kilogram mass should come in. So the amount of heat energy that we shall need in order to change 1 kilogram mass of a ice cube into liquid state at a constant temperature is what we shall refer to as the specific latent heat of fusion. Then that amount of heat energy that we need in order to change 1 kilogram mass of maybe ice to liquid is given by the mass of the ice times the specific latent heat of fusion. Now, the value of specific latent heat of fusion is a constant, and it will always be provided to a learner. Well, or in some other cases, you'll be required to find it given other quantities. Well, so we shall denote that heat energy that is required as Q, and then the mass of a substance, we shall denote it with M, and then we say the specific latent heat of fusion, we shall denote it with LF. Now, when you are to look at the SI units of the specific latent heat of fusion, well, we know that this is amount of heat energy that we need. So this heat energy Q is in joules. And then the mass of a substance its standard units are kilograms. So if we need to come up with units of LF, which is the specific latent heat of fusion, we shall basically divide this heat, which is in joules, divided by the mass, which is in kilograms, and then we shall have joules per kilograms as the units of specific latent heat of fusion, the LF. Then next we are going to look at the specific latent heat of vaporization. Now the specific latent heat of vaporization occurs or applies to substances, like maybe if you're to look at water, and this water we are boiling it. Then once it hits its boiling point, which is 100 degrees Celsius, and then it will have to change its state once it hits the boiling point, which is 100 degrees Celsius. So this water, as it is changing state from liquid to vapor or gaseous state. Now, if we have 1 kilogram mass of this water that is being converted into vapor, so the amount of heat energy that we shall need for that 1 kilogram mass of water to change into vapor is what we shall refer to as the specific latent heat, basically. Okay, so the amount of heat energy that we shall need in order that to take place is what it will be given by the mass of a substance multiplied by the specific latent heat of vaporization. And we say that this amount of heat that is going to be required, is we are going to denote it with Q. Then this mass, the mass, we are denoting it with M, and the specific latent heat of vaporization, we shall denote it with LV. So this formula of the amount of heat that we need in order to change 1 kilogram mass of a substance from liquid to gaseous state, these formulas are more or less, okay, they look the same, but it is only these constants, the latent heat of fusion and the latent heat of vaporization, that do change. Okay. Likewise, if you're to go to the units of specific latent heat of vaporization, so the same thing applies. So this is the amount of heat energy that we need, which is going to be in joules. Then this mass here is in kilograms. Now we need to find out the units of LV, which is the specific latent heat of vaporization. And then if you are to make it the subject, you realize that we shall have our heat energy in joules divided by the mass, which is in kilograms, and we shall have the final units of specific latent heat of vaporization as joules per kilogram. Now from there, we are going to proceed and do some 2 examples. Okay, the first example is, we have the specific latent heat of fusion of ice, which is 340,000 joules per kilogram. What do you understand by this statement? Well, now this statement here means that we need 340,000 joules of heat energy in order to convert 1 kilogram mass of ice from solid state to liquid state at a constant temperature. Okay, so here it means that 340,000 joules of heat energy are needed in order to melt 1 kilogram of ice into water without changing its temperature, just like I told you. So the change of state occurs at a constant temperature. So the learner should not forget this aspect of the temperatures remaining constant as the change is taking place. Okay. Part B is, how much heat is needed to melt 300 grams of ice at 0 degrees, given that the specific latent heat of fusion of ice is 3.36 exponent 5 joules per kilograms. So we have to recall our formula here, that the amount of heat energy needed is basically the mass of a substance you are looking at multiplied by the value of the specific latent heat of fusion. Okay, so say that amount of heat energy that we need, we are denoting it by Q. The mass of the substance given to us is 30 grams, and therefore the first thing that you have to do is to convert the 30 grams to kilograms. So we do that by dividing the value given to us in grams, we divide it by 1000, and in so doing we are converting this mass of 30 grams to kilograms. Then we are going to multiply it by this constant that has been provided to us, which is the specific latent heat of fusion, which is 3.36 exponent 5. Well, so after simplifying this, it leaves us with 0.03 multiplied by the value of the specific latent heat of fusion, and after computing, we're remaining with the amount of heat energy that we need in order to convert 30 grams of ice at 0 degrees Celsius as 10,080 joules of heat energy. Well, so we don't need to forget this, the units, which are joules. This is heat energy, and energy is in joules. Okay, so we go to the second example. How much heat is needed to change 40 grams of water at 100 degrees Celsius to steam at constant temperature? The specific latent heat of vaporization of water is 2.3 times 10 times 10 power 6 joules per kilogram. Okay, so just like I told you, our formula here should be at the back of our mind. The amount of heat that we need in order to change the state of a substance is basically the mass times the specific latent heat of vaporization for the case of converting maybe a solid to, or converting a liquid to vapor form. For example, water to steam. Okay. Now the mass of water given to us is 40 grams. And what we need to do is to convert the 40 grams of water into kilograms by dividing by 1000. Then we shall multiply it with the value of specific latent heat of vaporization, which is 2.3 exponent 6 joules per kilogram. And when we go ahead and simplify, 40 divided by 1000 leaves us with 0.04 multiplied by 2,300,000 joules per kilogram. So we have here joules per kilogram, and here we have kilograms. So that means kilograms divided by kilograms, the kilograms will disappear, and then we shall remain with our amount of heat that we need in order to convert 40 grams or to change 40 grams of water at 100 degrees Celsius to steam, being 92,000 joules. I want to thank you so much for viewing and listening to me. Please subscribe to my channel, follow, like, and share with your friends.